it's great when Cynthia says so nice to me. I think this meeting is an example of the amazing work that Cynthia has done in developing the Center for Evidence-Based Crime Policy. This is an idea that she and I had 3 years ago. Indeed, one of the reasons I came to George Mason was that Cynthia was here, and I knew that together we could create real innovation. Innovation here is not only about innovation, the idea of science, or even about innovation in the area of practice. It's about integration of the two. And that's what this session really is about. I'm really just sort of leading us into Renee talking, because Renee is going to talk about a case where a police agency decided to work on a science-based model. The title of this short presentation I'll give is Science and Policing. It's also the title of an article published by the Harvard Executive Session in Policing that Peter Nayrud and I have written. Peter Nayrud is the chair of our advisory board, was also the director of the National Police Improvement Agency, and now has decided to take some free time and have fun and do a PhD as well. So, but the idea of science and policing is about science being important in policing, about the police taking ownership of science. Because when you use the term science, the typical response would be, oh, science, that's in the university. I don't have time for that. We have real practical things to do here. I don't have time for that kind of stuff. You know, it's not important to what I do. And Peter and I and others and this center, Cynthia and I, our work in a sense is trying to change that. And what it means is that we want to take science on its most cutting edge and most elite, if you want to call it, status, and we want to take the best practices in policing, and we want those things to be completely integrated. And what do we mean by that? Well, you might think that there are alternative ways that police can innovate, but it's not only about innovation. It's also about just deciding what practices you're going to use out there. What are going to be the everyday programs and policies of the police? Well, in a way, you can think of two ways in which to develop that. And the real world is often mixed up a bit. But one would be what we might call the clinical experience, or the opinion model, as Steve Mostrovsky calls it. And here what you have is that innovation is identified, it's developed, it's diffused, in other words, goes from department to department, based on the opinions, experiences of practitioners. Now, is this a bad thing? No. Bill Bratton is a great guy, very smart, has really good instincts, great experience. He has a lot to say about what you ought to do in policing. But the important issue here is that in the clinical experience model, clinical experience is the basis for decision making, not just one part of the process, right? In other words, all the decisions we make on the basis of clinical decisions. I've had this experience, that tells me it's a good idea. Is that useful? It is very useful. But should that be the only basis for decision making? And there lies the problem. And that's how you get the evidence-based model. In this case, programs and practices are based on science and clinical experience. Let me give you an example. I call it the good physician. I was at a meeting of the Israel Democracy Institute in Israel on the police. And at one point, one of the police officials came up and said, oh, I don't have time for this research stuff. It's not relevant to me. I was surprised because there was a member of the Knesset there and others. So usually someone doesn't want to say such a thing, but I thought it was good in a way that it was said. Because I said, well, wait a minute. You know, when I go to a doctor, because I'm not well, I want that guy to have clinical experience. By that I mean, I don't like to go to doctors that are too young. I like doctors with gray hair like me. You know, I want them to know what I want them to have a lot of real experience of what's happening on the ground. And to be frank, I'm very distrustful of very young doctors. At the same time, if the doctor comes to me and says, I don't care what the research says about whether those drugs work, I don't care about the research says on whether those interventions have bad outcomes, I don't want to know that's for researchers, not for me. I'm like, I wouldn't go to that guy either. I want someone who's going to know the most up-to-date, have the most up-to-date knowledge on what the best medications are and the best therapies are and what their likelihood of working, etc. And I also want someone that has real experience that can adopt those, quote, scientific findings to the realities of me, to to the realities of my situation, the realities in the case of the police, of the specific situation of the police. So in such a situation, programs and practices would be developed by, what do we know? What does science tell us? What are the best ways to allocate patrol? And then that same police chief and his commanders, and maybe others in the department, will say, let's think about how that would be best adopted here. My experience here tells me X. And that becomes integrated. And then, as a next step, if you like, they're going to say, well, let's try it. Let's try it maybe in a few places or with a small group of officers and see how it works here. Let's learn a little bit about it. And let's not widely diffuse it in the department until we've had some evidence, our own evidence from scientific study in our department about whether those program practices make sense. And this is precisely what Renee has done, by the way. She's going to tell you a story about how she came to learn about research evidence about police patrol. And then she's going to tell you a story about how she developed a patrol approach in Sacramento to fit that scientific knowledge, and how she had the department do it on a pilot basis to make sure that kind of approach would really work in Sacramento. And she used the best scientific methods to do that, methods that you could really believe in. Now, here's the risk of a clinical experience model, right? Here's what usually happens in departments. You start out with some need. By that, something's bad. The mayor comes and says, man, we got all this drugs going on in the street. There are drug markets everywhere. I want that stopped. Do something. The chief and the captains, they sit together and say, guys, what are your experience? What's the best way we can handle this? And by the way, don't get the impression at all that I'm debunking that experience. I'm not saying that experience is not worthwhile. It's critically worthwhile, but it's not the only thing that's important. Research evidence is important. Let me give you a quick anecdote about clinical experience that should let you know this. There was the first experimental study in criminology, and I'll tell you a little bit about this later, about what an experimental study is, but was a study called the Cambridge Somerville Youth Study. And in that study, they used all the knowledge at the time about what would help kids who were in trouble. So they chose a group of kids, and they gave some kids the treatment, and some kids didn't get it. The treatment was everything they knew. It was a social worker intervention, camps, all the kinds of interventions people thought were good for children in the late 30s and early 40s. And when they interviewed the practitioners about the program, as it was going, they all said, this is the greatest thing since sliced bread. It's great. We're getting to do all the stuff we really know how to do. We're having great effects on these kids. We can see it. A follow-up of that study 10 years later found that the group that received the treatment turned out to have more serious criminal careers than the group that didn't. It backfired. So you got to be really, clinical experience is really important, but sometimes you can't see certain things. It's very important to use science. Anyway, you get a clinical response, meaning you develop some program to do it. You get support from people, right? Get the guys on board and get them excited. You widely diffuse that either only in the department or maybe if it's small departments or whatever to other departments as well. And then what often happens is researchers or others or the city manager, people come in, they look at it, and there are challenges to the success of the program. And then you have criticism. People say, why'd you do it in the first place? Now, I'll give you an example. It's going to surprise you. Comstat, New York. 1984, Comstat starts. Bill Bratton, very innovative guy, brings in a program that made a lot of sense. It was based on some good ideas from researchers as well. And then 1994, 1998, they look at it, my God, the murder rate, the violent crime rate, it goes down like 50%. He gets on the cover of Time magazine. But then people started to take a look. It turned out that the declines in New York were not dissimilar from declines in other large cities on the East Coast at the same time. It also turns out that the decline in crime in New York started not in 1994 when Bratton came on board, but 1992, 2 years before he ever came on board. The point I'm making is that quite often what happens when you use a simple clinical model without using strong scientific evidence and evaluating it well, is that along the way, things sort of go bad. After all the excitement, things didn't meet what you wanted, and then you sort of left in the lurch saying, I invested this all and it doesn't do anything, and you get lots and lots of criticism. Now, hopefully at least, this is the model for a evidence-based model, which is because you're relying on existing knowledge, because you test those programs and practices before they're widely diffused, all right, you minimize your risk. In other words, you minimize the likelihood it's all going to go wrong. I mean, you can look at it that quite often in the clinical experience model, what happens is it's all driven by politics and propaganda on one level. A lot of times good clinical experience, but then it's, I know it works, et cetera, et cetera, et cetera. But you're not, in a sense, assessing all that at a level that you'd want someone to assess medical interventions, for example. In the same way, whether you really want to know whether those medications are working or not, we also want to know whether priest practices are working. And the evidence-based model is a good way of ensuring that. So a lot of people say that the evidence-based model is a bad idea. In other words, it's more costly. I have to do more thinking. It can go a bit more slowly. All of those concerns can be raised. But the opposite side of this coin is you're actually minimizing your risk in the long run. You have a systematic process for knowing whether you're going in the right direction and then assessing that direction as you move along. Now, Renee is going to tell you about a randomized experiment in Sacramento. Now, let me just tell you why randomized experiments are such a key and important part of evidence-based approaches. We have a technical term. It's called internal validity. You don't need that technical term. Internal validity, I've defined here, is the extent to which a study can be confident that the effect observed is the true effect. Well, it's quite simple. Internal validity is about believability. Can I believe that the effect I'm observing, the outcome I'm observing, is really there and not due to something else? Like the worst, most insufferable types go to prison usually, right? So it's very hard to assess the effects of prison because we have what we call selection bias. The guys who are in there are in the first place more likely to recidivate. So you have to be really careful. It's very hard to control out for those things. You can think of it almost any time we select people into a program, in any way or form, we have a selection bias. In New York City, what was the bias in New York City with Comstat? 1994, 1998, violent crime rates went down, 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 down. Well, they went down. It had to be the police. There's an internal validity problem. Can you believe it was the police? What's the problem? What happened between 1994 and 1998? The economy was getting better. All sorts of other things were happening. In American cities in general, any study you did that you looked at time one versus time two in America in the 1990s was a success. Because crime rates went down in that period, averaged 25% nationally for violent crime. Juvenile crime even more so. So these are all problems. So how do I know? How can I tell whether it was the program and not something else? Well, that's what a randomized experiment does for you. And it's the simplest idea in the world. Actually, practitioners should like randomized experiments. Academics were unhappy with randomized experiments a bit, and I'll tell you why. What you do is you take 100 people, 100 places. You put them in a package, and you throw them up in the air. And you take 50 places that fall on this side randomly and 50 places on this side. In other words, the only reason why a group ends up in the treatment group and the control group is chance. Well, what we really do is we randomly allocate them. So we enforce that. We randomly allocate them. So there's no reason why the treatment groups, every person has an equal probability of getting in the treatment group or getting in the control group. Well, if you had, every person had equal ability to get into treatment and the control group, what's true about those two groups? What are they? Are they different? They're pretty alike, right? I mean, if there's another way of saying it, a statistical way, is there's no difference why any individual should be in treatment versus control. So everyone, it's treatment and control groups just by chance. Do I have more? Are these people more motivated? The guys in the treatment? No, because everybody had an equal probability of getting in. Well, what that means is now I give the treatment or the intervention to the treatment group. And afterwards, the treatment group does better. What's the explanation? Can it be anything else? Nothing else is different between those two groups, or at least you can assume the two groups are alike because it was random whether they got in one group or another. In other words, as opposed to every other way we can do things where there's some selection bias. The mayor wants these places. Think of they're all selection biases. They're all reasons why one group would have done better than another. Well, in this case, we've got two groups, and the only reason you're in the treatment versus control is random, chance. So if you did better, the only thing different besides chance was the treatment itself. So randomized experiments are the greatest way of identifying whether, in fact, a program or practice was successful. It's the only way of getting rid of everything else. And I'll just tell you why academics often, like a lot of researchers will come to your department and they want to, well, not a lot, but some, maybe less and less all the time because of people like me, I suspect, and others. But they'll come to your department, they'll want you to do some other type of study. They'll want you to do a multi-level, hierarchical, randomized, regression analysis with 64 parameters, 32 this and 42 that. And they come in, I call this the cloak of science. After 3 minutes of talking to them, you don't have the slightest idea what's going on. You just say, my God, they seem so knowledgeable. Let me just give you a quick example to show you on how high a level this can happen. It's not only cops. There's been a large issue about fairness in sentencing and the death penalty in the U.S., right? And one of the things that happened with that was that Supreme Courts in most states that have the death penalty have invited advisors in to tell them or develop systems to see whether the death penalty is administered fairly. And in New Jersey, the state invited in a very well-known academic who had done, actually was the person who did the Georgia work for the Supreme Court, if you know this work at all. They brought this fellow in, and he did an analysis with them that was a logistic regression with X number of parameters chosen through all sorts. It has a 25-page technical appendix, which I could just read, all right? It was very, very technical. So they adopted a system, and that system had this regression format that gave them, in the end, a number. And that number told you whether that person deserved the death penalty or not, right, on the basis of all those characteristics. Anyway, so they did this system, and they started operating on it. They actually used it in a case or two. And the defense, of course, started raising issues about this and brought in a statistician from Penn who said there are problems with this system. So then the Supreme Court brought me in and said this was a mistake. Don't go in to clean up other people's problems. It's a gigantic mistake because they're not yelling at you. That's what happened. So they brought me in. They told me, gave me these documents, and I read through all the appendices. And I said, look, did you understand that there's something called a confidence interval? It's how confident you can be in something. So I said, did you understand the confidence intervals around these estimates went from 0 to 100? That means you cannot be confident. In other words, the true value is either between 0 and 100% likelihood. It has a mean value, it's like depending on the person, but the true values, in other words, the statistics say that you can't really believe them, like you can't believe many non-experimental studies. So I had to go to the chief of the Supreme Court and say, I don't know if you know this, but this, I wouldn't make decisions about the death penalty and this stuff. And she said, well, why was it published in the Journal of Applied Statistics? Well, I said, because they used a new automation method for solving a problem. It wouldn't work. And they found a method around it. And I said, that's really innovative. I said, but I wouldn't base someone's life on a method that has no precision, for God's sake. Well, I had a week of calls every night at 1 in the morning because I was in Israel at the time, and the head of the Supreme Court was in the U.S. She called me at 5 or 7 at night, 2 in the morning, for an hour and 2 phone calls, because they had already issued a precedent about this thing and had to figure out a way to undo it. Now, the point I'm making is that when I didn't want to say the name of the person, when this person went and brought this idea to them, and if you want afterwards, it's a lot of technical stuff. Anybody interested, I'll tell them the story of this. But when he brought them the idea, he said, I have the cloak of science, and I'm doing the best science. And he was doing not bad science, but it wasn't reliable enough for practitioners to make good decisions. Now that's what we're about. We want you to understand the science. And why we use experiments is because it's the best science, and it's really, really easy to understand. You all now know from a 2-minute discussion, if you didn't know before, why randomized experiments work. It's because you throw up those balls in the air wherever they fall, 2 groups, exactly similar as, there's no reason for them to be dissimilar. One group gets treatment, they do better, it must be that group. So wait, Renee deserves a lot of credit because I know of very few police agencies that have on their own, we had no grant to do this, we helped Renee because we are, it's like we're public servants like many of you guys. We want to do good for the world. We want to see this evidence-based work move forward. Okay, let me just tell you about one more thing, and then my time is up. Well, I'm not going to say a lot about this. Are experiments ethical? Well, this is always an issue. Is it okay for me to give certain places treatment and not others? Or to give certain people treatment and not others? I mean, that's an issue that people raise. Well, the first point just some quick points about that. The first is that what is the fairest way to give treatment if you can't give everybody treatment? When you start a new program, you don't want to do it for everyone. That's a waste of money. So you want to do a small number. And when you pick that small number, isn't picking it randomly the fairest way to do it? In other words, there's no bias there. I have 500 hotspots in the city. I want to try a new program. I'll try it with 20 hotspots. I want to choose them randomly. That's great. I've chosen them randomly. No one can complain that I've given one person more treatment or another person less treatment. Let me just say something about why it's not ethical to develop programs without the best evidence about why they work. I mean, you're public servants. You need to provide to the public, especially in these times, the most efficient and effective programs you can. That is your ethical duty as well. You have an ethical duty to do that. And I, as a scientist, with you, have an ethical duty to make sure you get the right answers. That first person in the Supreme Court in New Jersey did a disservice. He gave the Supreme Court the wrong answers. He didn't explain to them how much they could believe in those answers, right? Experiments are very believable. Afterwards, you can believe if there was an effect, it belongs to the treatment group. My own view is there are sometimes ethical issues in experiments. Sometimes you have to think carefully about what if I give a program to one group or not to another, etc., and how that works. It's very important. Very seldom does that stop you from doing it because the realities are you can't give everyone the program at the same time anyway. But the other side of the coin is to give people the wrong answer. For you guys to be carrying out strategies and you don't know whether they work or whether they're harmful, that to me is an ethical violation. If you can get a better answer, you should get it. And this is the best way to get that answer. And Renee is going to tell you about how a police department can do it without a lot of resources and come up with important advice for the department. Okay. I can go 5 minutes over? A few more minutes. Okay. Let me just go quickly what I think has to happen for evidence-based policing to succeed. The first is that scientific research must become a natural and organic part of the police mission. Up till now, for the most part, science is for us on the outside. The police departments have their own mission. I don't believe that. I believe you guys should be now. Everybody I work with, Jim Bierman, knows too much about science now, he always tells me. You should understand and know what's going on. It should be integral to what you're doing. You should know about it. You should understand it. You should see it as an organic part of your department. Imagine the best research corporations in the world without the best, companies like Motorola or GE, and they have no research divisions. They have no understanding of the importance of science for what they do. Science must become a natural part of police education, and police education must be based in science. Peter has most stressed this to me. Quite often, cops in their education, we looked at this, there was a European study, they learn about the laws, right? But they don't learn about what the science tells us about the strategies and approaches. That kind of knowledge is very important to what the police do. It must become a part of their everyday education. Science and policing must answer questions that are critical to the police function. Now let me say that one of the problems of science has been the scientist. They don't care about the things that are important to you. They just don't care. They don't care about investigations. They care, a lot of science in the US and criminology has been very sociologically based. They have never had an interest in the everyday problems of the police. Science and policing must answer the everyday problems. The National Institute of Health spends billions of dollars over time on issues like how do I deliver the treatment? They know the treatment works. Well, how do I deliver it? How can I diffuse that treatment across different medical clinics in the US or across the world? By the way, the Department of Justice is just beginning to become interested in these questions. The National Institute of Justice now is developing a program on how do we make it so that police departments can translate knowledge across departments, etc., or that science can be translated across departments. Laurie Robinson, Phelan, Warwick, and others are key in this process, as is John Laub, the director of the National Institute of Justice. Finally, the answers must be timely for the police. How many people have worked with researchers here? How often are those researchers so late it becomes ridiculous, it's no longer relevant? Too often, right? So researchers have to change. And that's a reality. That's an issue our center is dealing with. It cannot be that 10 years later it comes out. For the everyday world of what you're looking at, there are some studies that have to be done over time. But for that knowledge to be useful, as you to integrate it in the department, it has to be something that occurs within your time span, not the time span of academics. I think I've said, you can look at the last slides, you have them, but let me just say something else that those slides get at. Those slides reiterate the idea that you have to introduce science. You have to take responsibility. I gave this talk at one place, I forget where it was, and I think it was in Israel actually, and the police people yelled at me and the academics yelled at me. They both yelled at me. Why? Because the police people yelled at me because I was telling them that they had to take responsibility, that they had to become the arbiters. Don't let other people control your life. Take some control. What are the questions you need answered? You should know that you need to do it the best way possible. You should be integrating academics, education, etc. in your department. You should be making sure that police in your department know what the Kansas City Preventive Patrol Experiment is, or the Minneapolis Hotspot Experiment is. They should know what the Campbell Collaboration is. That should be something you're doing. And there are departments like Jim Bierman's department in Redlands, California that do that. But on the side of academics, it's something else. You can't just create questions all the time that you're interested in because 8 scientists want to hear about them. You have to start answering the core questions of policing. You have to be interested in the real world of policing. Right now, unfortunately, in the academic world of police research, of academic criminology, policing is not the top specialty in the sense that everybody's thinking of policing as a high status group. The policing journals are not high status. I think the problem is because we haven't really attacked the police function like medical research has attacked the medical function, or even the education research now has attacked the education function. In other words, we have to be relevant, and that's not something that we are today, and academics don't like that. In other words, we have to start, when we come to a department, we have to say, what are the critical issues? We just finished the study at the Police Foundation on shift work, right? We did a randomized experiment in which we compared 8, 10, and 12-hour shifts. Is that important out there? I think it's important in policing. Most academics wouldn't even think, I can see someone saying it's not theoretical. Where is the sociological basis? I don't know. It's a critical question in policing and can be answered by really good science. By the way, we found that the 10-hour shifts had the most benefits and least liabilities. If you're going to shift from the 8, you can go to the 10 without much liability. Don't go to the 12s. People start getting tired. There are eye tests and other things that show that you're beginning to get fatigue. They're not happy or interesting enough than the 10s. So the 10s is a good choice. But that's the kind of practical everyday questions that we need to answer. There needs to be an integration. Just as a last comment, John Shepard, who's a Stockholm Prize winner, has recommended that there develop police centers, academic centers. What do you call them? They're called university medical centers. It should be university policing centers, where we have, where very large departments will have academic units located in those departments. We'd have clinical professors, meaning police officers, become intricately involved in the carrying out of research, etc. These are all dreams at the moment for the future. I think it's part of the future if we succeed.